In this video, we're going over the recursive approach of best time to buy and sell stock for. So you're given integer array prices, where prices I is the price of a given stock on the ith day, and integer k. Find the maximum profit you can achieve. You may complete at most k transactions, so each transaction is a buy and then a sell. You may not engage in multiple transactions simultaneously. You must sell the stock before you can buy again. So in the first example, we're given the maximum transaction we can make is 2, and then we're given this prices array. So the maximum profit we can get is buying on the first day and then selling on the second day. So we get a profit of 2, and then we can perform no more buy and sell. So the maximum profit we can get is just 2. In our second example, we're given k is equal to 2 and our prices array. So we're going to buy on the second day and then sell on the third day. So we get a profit of 4 here. And then we're going to buy on the fifth day and then sell on the sixth day. So we get a profit of 3. So 4 plus 3 is equal to 7. And we only performed at most 2 transactions. Let's go over the dot process. So we will first implement the recursive approach. So we have 2 possible states. So we have a buy state and a sell state, which we can denote as 2 integers. So we have 0 is equal to buy, and then we have 1 is equal to sell. When we are currently at the buy state, we have 2 choices. So we want to buy the current stock. So let's say for each of the index I. When we are currently at the buy state, we have 2 choices. So we want to buy the current stock at index I and transit to sell state, or skip the current stock. Then we will want to pick the choice that will give us the higher profit. Now, when we are currently at the sell state, we have 2 choices. We can sell the stock at the current price and transit to buy state, because after we sell, we can buy again, or just skip the current stock. Then we will pick the choice that will give us the higher profit. Well, and a side case we have to consider is the k number of transactions that we are allowed to make. Every single time we perform a buy and then sell, we will need to decrement the number of transactions. Let's go over the pseudocode. So we're going to implement the recursive approach. Now, what parameters do we need? We'll need I, the current index we're processing, and then prices, and we also have our state, the current state. So initially 0 for buy, because initially we're at the buy state, and then we have k, the number of transactions left, and then we have our prices input array. Now, what's the base case? If I is out of bound, this means we have no more stocks left, or k is equal to 0. We can perform no more transactions. This means the maximum profit we can get at this point is 0. So we're going to return 0. Then each of the recursive call, if the current state is equal to 0, which is our buy, we're going to recursively find the profit P1 if we buy the current stock. If we buy the current stock, we increment our index to index by 1, and then we're going to transit our states to sell. Then we're going to recursively find the profit P2 if we skip the current stock, which is just moving our index forward. Our states stays the same. We're currently still in the buy states. And then we'll return the maximum between the 2 profits. else we are currently in the sell state. We're going to recursively find a profit if we sell at the current stock or sell at the current price. If we sell the current price, our index still moves forward, our states go back to 0 because we want to go back to our buy state again. And then the number of transactions will decrement by 1 because we perform a buy and a sell. Now we want to recursively find the profit, P2, if we skip the current price, which is just moving our index forward. Then we want to return the maximum between P1 and P2. Now let's go over the time and space complexity. For the time complexity, we get O of 2 to the n, where n is the length of the input array. Each recursive call has up to 2 choices and a depth of n. Our space complexity is O of n. This is our recursive call stack memory. Now let's go over the code. So we're going to implement the recursive approach, keeping track of our current index, the current states, the number of transactions, and our input array. If I is out of bound, or k is equal to 0, this means we can find no more profits. If I is out of bound, there are no more prices or there are no more stocks to process. If k is equal to 0, we can perform no more transactions. So we're going to return 0. Then if state is equal to 0, we're going to find the maximum profit. We're going to find the larger profit between if we... Oh, this one more thing we need to do. Because after we buy at the current stock, we need to decrement by the current price. And then if we sell at the current stock, we want to increment by the current price. Now let's go back to the code. So maximum profit, if we buy at the current stock. So if we buy, we're going to move our index forward and our state go to 1. And then the number of transactions stays the same. And then we're going to decrement by the current price because we bought the current stock. So we want to decrement the amount of money we have. And also the maximum profit if we just skip the current stock. Else, we're currently in the sell state. So we want to return the maximum profit between selling at the current price or skipping the current price. So if we sell at the current price, we want to go back, our state turn back to 0 and our number of transactions decrements by 1. And then we're going to increment by the current price. Or we just skip the current stock here. Okay, we're getting our TLE error. So this approach is not efficient enough due to overlapping recursive calls. So in the next video, we'll be going over the memorization approach where we perform an optimization to the recursive approach. Let me know if any questions in the comment section below.